Alright, I just finished the anaerobic stage of my mineralization or nutrient reclamation. What I do is I let it set anaerobic for a couple of days, a few days. I think this time it's been about 3 days, 3.5 days. And I just started the air. So after the air and mixed it for about 5 minutes. After the air had mixed it for about 5 minutes, I took, or even less than that, I took some readings. Check it out. This is ammonia. Can we see it in the light? It looks dark. I can't even, it looks dark. And part of that is because there's sediment at the bottom. But part of it is because, okay, let's see, we get it behind the sun. You can kind of see. I've never seen ammonia so dark before. Holy crap. So that's dark green. And I guess this is like I mean, it's turned blue. I don't know. And then the other one is phosphate. And again, very, very dark. There we go. Come on, autofocus. Very dark. And the darker it is, the more phosphate's in there. And I lost my card, but that is as dark as I've ever seen it. And let's see. You can kind of see through it a little bit. Oh, that's so pretty. Alright. Very blue. So now I've got the aeration going on in my, there we go. And this last time I've got some tomato trimmings in there. I've got some leftover grass. But the latest stuff I put in there was, wow, those tomato trimmings are gone. The last stuff I put in there was the sediment from the bottom of one of my swirl filters. I drained that out. And I have added, this time I have not added any more of that clay stuff, but I did add calcium carbonate, lots of it, like maybe a cup's worth, and also potassium carbonate to get the pH up, ostensibly to stop the conversion or production of hydrogen sulfide, which partial success. But I have learned potassium carbonate ups the pH way more, to a far greater degree than the calcium carbonate or the I also put wood ash in there that I had sifted out. I burned a tree limb that I cut and I turned that into an ash pile, and I put it was 8 plus 8 tablespoons. So whatever that is, 16 tablespoons of wood ash, and it bumped the pH up of like 50 gallons of water by, it went from 7.7 to 8.0 I think, or 8.1, so not very much. Whereas one cap of the potassium bicarbonate brings it from 7.5 pH, 7.5 to 8.9, like that. You can kind of see the remains of some of the tomatoes. There were green tomatoes floating in the water. And now they're just like skin. And yeah, that water is pretty murky. And I'm always careful not to get my hands in it if I've got any cuts on my hands, because I've had some close calls here and I've read some gnarly stories, and the bacteria that I'm playing with here don't play nice in the human body. They get a little too comfortable. So I'm very careful. I got my stick. So the phosphate levels are high. Ammonia levels are high. The anaerobic bacteria are either going to become obligate aerobes and start and get with it because we're aerating now, or they're going to die off, and we're going to have some aerobic bacteria continue the breakdown process. I don't think they break down the material though. I think what these guys do, the aerobes, I think they convert the available nutrients in the water into a biologically available form. and a form that doesn't show up on the test, on the phosphate test. Phosphate's on the right, super dark, right? They're both super dark. After the aeration, we're gonna find that the phosphate levels are much lower, much lighter in color. Why is that? I think it's because the phosphate's in a form I can't test for. So the aerobic bacteria are going to eat up that ammonia, and I believe that they, instead of converting it all the way through to nitrate, I think it gets gassed off as nitrous oxide. That's what I read. But regardless, I've got super high ammonia right now. After the aerobic section of or phase, the ammonia will go down to 0. That's when I stop the aeration and I know I can decant my water, is the ammonia goes to 0. But shocker, the nitrates also go to 0. So where's all that nitrogen going? It starts off as ammonia, we measured it, and then aerobic phase, and now there is no nitrates in there, no ammonia either, and no nitrites. So I'm thinking it's gassing off as N2O, but I don't know. But you can't argue with the results. And actually last week I flooded out my system, left the hose running for an hour. So I'm sure any nutrients that were built up in the water got diluted to nothing. But I was lucky because I had I had a tank of a nutrient reclamation tank. Oh, there's yellow jackets all out here. I'm afraid I'm going to get stung. Nutrient reclamation tank batch was just about ready to go, so I put that in there, and none of these plants seem to show, oh, I'm needing this, I'm needing that. The squash and the pumpkins are always needing calcium, it seems like, but everyone else seemed pretty happy, and so I was pretty happy with that. Yellow jackets are, oh shit, sorry guys, and apologize for my language. I'm allergic to these guys, so I swell up. And I pulled off 6 to 8 cucumbers off my cucumbers in there. My strawberry is like in a little cave covered over by cucumber and tomato plants. Tomato plants got these nice stripy green guys going, and they're everywhere, all throughout. Look how far this has gone, all the way to the end of the trellis. Hey Chris, you're in my video now. Okay. And the cherry tomatoes are the same way. They are happy. So this is really doing well. I think this is good. This seems to be a way to make everything available to the plants. I'm adding potassium and calcium carbonate, and I don't know what else. Maybe I need to, but I'm not adding iron, and so everything seems to be doing good. This is it seems to be a very effective way of delivering nutrients, either to the plants or to the microbes that serve the plants. And yeah, maybe I ought to replace this with a 100-gallon tank instead of 75.